gonna go over this 2025 AMC 8 for the second last question, question number 24. Let's read the question. In trapezoid ABCD, angle B and C measure 60 degrees, and the two legs are equal, AB equal to DC. The side lengths are all positive integers, and the perimeter of ABCD is 30 units. How many non-congruent trapezoids satisfy all of these conditions from 0 to 4? So before we give the solution, we're going to give you a few strategies related to this question. First, the strategy about the trapezoid. For example, given this trapezoid ABCD, we can split the trapezoid into different shapes. But the first thing we need to be careful, we don't want to do the extension from the two legs. So that means we really need to be careful about this splitting. And I'm not going to do from the top. This usually people try to split the trapezoid or reshape the trapezoid into a triangle on the top and entire thing. That's not correct. So the actual way to split the trapezoid, we're going to do this way. This is a common strategy. We're going to split the trapezoid into a parallelogram and the triangle. There's two different shapes. This is the common way to split the trapezoid. So we're going to do parallelogram and also a triangle split into two different shapes. That's a common strategy. Probably a lot of people familiar with the other method. They're going to split the trapezoid into three different shapes. Three. So let's take a look at this one. They're going to split this way. They're going to split like two right triangle, and also the middle one is a trapezoid. Okay, but this is a strategy mainly for isosceles trapezoid. That means the two legs are equal, AD equal to BC. So for the regular trapezoid, general trapezoid, we don't do this method. Only we do the splitting when AD and BC, the two legs are equal, we're going to split this method. So, but a lot of people really like this method, but that's not a general strategy then. So this is about the trapezoid splitting strategy. Regarding the question, we have another method about solving the Diophantine equation. Diophantine equation, what is the Diophantine equation? I mean, I'm going to get this multiple variable, x and y, they are all integer solutions with the sum coefficient a, b, and c. Let's see what is the way to solve such a Diophantine equation. This example, 3x plus 5y equal to 25. You can look at the two things right here, 5y and 25. These two is divisible by 5. So therefore, in order for them to be integer, this x must be multiplied because this 3 is now multiple 5. So you have to guarantee x is multiple 5. So also you make sure there's going to be positive integers. So 3x has to be less than 25 so that this one also not equal to 0. At least you're going to get a 1 for it. So 3x must be less than 25 as an integer. X at most going to be 8. But we also have the x must be multiple of 5. So in order to satisfy this x less than equal to 8, the only condition satisfied is going to be for x equal to 5 within the range. Less than equal to 8 positive value, but multiple of 5. So the answer should be 5. So after you plug back into the equation, we also get the y value. 5y equal to 25 minus 3 times 5, 15. So you get a 10. Y automatically get a 2. So we get the solution. We only get one pair of the solutions. 5, and a 2. So this is the one way to do it. This commonly we use this like a multiple of some integers to solve for it. That's just a simple one. And we have another way using a little bit more advanced method we call modular. Modular method is going to be more advanced, like a combination based. So same example, 3x plus 5y equal to 25. I'm going to take the modular 3, which has the less coefficient on the left-hand side. You see, one is a 3, one is a 5. I'm going to take the smaller one. So I take the modular 3 on both sides. And then you're going to get this one become 0. This 5 divided by 3, the remainder is 2. So the left-hand side only have 2y. So the right side, 25 divided by 3, the remainder is 1. So 2y congruent to 1 modulo 3. But in order to solve this y, this one must be multiple of 2. But this one is not good. So let's just add the multiple of 3 onto 1. I just add 1, 3 should be good. 1 plus 3 equal to 4 modulo 3. So in this case, using the modular arithmetic, we can find out the y value, which is 2, 4 divided by 2 is 2, congruent to 3. And then we just figure out this value of y. But y is a positive integer, and also make sure the y has to be equal to 2 and a 5. If you get a 5, probably will be too big because this has to be less than 25. So in order to make this a positive solution for x and y, so y cannot be equal to 5. I can only get the value of y equal to 2. Once you get a 2, we plug in, you get an x equal to 5. So you also get the same solution. So this is using the modular method to do this one. Before we go to our problem, we also want to see the special right triangle, which will be used for our problem, and so that to find the relationship in the special triangle right here. 30, 60, 90 triangle, and you can see the relationship between the three sides. The ratio of the sides is going to be 1 to square root 3 to 2. If I know the short leg, in order to get the long leg, I multiply by square root 3. In order to get the hypotenuse, I just multiply by 2 from the short leg, and then you get this relationship. That means given any sides, I can find the other two sides immediately. So now let's go back to our problem. For this one, we have the parameter given ABCD. The base angle is 60 degrees. And then what we can do, we're going to do first method, we're going to just split the trapezoid into two shapes. Draw a parallel line DE parallel to AB. I'm going to let the leg is A, the top base is B. So given condition, all these sides are integer value. I'm going to draw this first method, split the trapezoid into a triangle and a parallelogram. Draw this DE parallel to AB. We're going to get the equilateral triangle CDE. Why equilateral? Because DE equal to A, this equal to A, this is the base is 60 degrees. So this will be equilateral triangle. And also CE is equal to the length of the leg as well. So therefore, we can find the parameter A plus A plus A, and also we have 2B. So given condition, the parameter is 30. So you get a 3A plus 2B altogether equal to 30. Now this is going to be the Diophantine equation we mentioned a moment ago. So you can see the relationship right here. 3A is a multiple of 3. 30 also a multiple of 3. In that case, you can see the B must be a multiple of 3. Okay, but 2B must be less than 30 because they are positive numbers. So that means B must be less than 15. But the number less than 15, but a multiple of 3, you get the value of positive value for b will be 3, 6, 9, 12. 1 times 3, 2 times 3, 3 times 3, 4 times 3. So you get 4 different values then. The answer is E, which is 4 different non-congruent trapezoid. As long as you determine the B, I can find out the value of A, and then you can determine the entire trapezoid. So this is the first method. The second method, so you can see I'm going to split the trapezoid into 2 congruent right triangle and also rectangle. This is the only I said mainly for isosceles trapezoid. What we can do, I'm going to let the top base to be y. I let this be after splitting as x. X may not be integer because this is not the side length. Side length of the trapezoid are integers, but this x is the part of the side length. Okay, and then we draw AE perpendicular to BC and also DL perpendicular to BC to split this into rectangle and 2 congruent right triangle. And also the right triangle is good. It's 30, 60, 90 special right triangle. So I let this one equal to x. The AB is going to be 2x because 1 to square root 3 to 2 for the special right triangle. And then AB is integer, 2x is integer. Doesn't really mean x is an integer. So the parameter going to be 2 times, this is 2x, this is 2x, 2 times 2x. And also this is the y, AD, EF is y, so 2y. 2x is BE plus FC, that's 2x. So the parameter equal to this, which is 6x plus 2y. But because the 2x is going to be the leg, that's an integer. I don't want to cancel the 2 yet because we don't know if the x is an integer or not. But a 2x guarantee is going to be integer. So AB equal to 2x is an integer, and also y is a positive integer as well, is given. The side length are integer. 6x and 30 are multiple of 6. So therefore, the 2y is an integer of multiple 6. So y is an integer of multiple 3 then. Okay, and then the y must be equal to 3, 6, 9, and 12, multiple of 3 integers. So we still get the same answer, which is E.